Hello, this is Mr. Stansbury. I'm going to take you through the 14 e-notes on theoretical probability. At the end of this, you should be able to say, I can find the theoretical probability of various situations, and I can find and interpret the complement of an event. Okay, so first thing is theoretical or mathematical probability, and that's the chance of that event occurring in any trial of the experiment. All right, so let's take a look at notation for probability, and then we'll talk about theoretical and mathematical probability. All right, so notation for probability, we have P parentheses E, so that's the probability of event E happening. Okay, so to figure that out, it's the number of members of event E over the total number of possible outcomes. Okay, for example, probability of rolling a number greater than 4 on a 6-sided die. So the number of members of the event that are greater than 4 would be basically 5 or 6. So it's really, we're finding out the probability of rolling a 5 or a 6. Okay, so there's 2 desired outcomes and there's 6 possible outcomes. Okay, so that means the probability of rolling a 5 or a 6 is 1 out of 3 or 0.33 or 33%. Any one of those 3 would be fine answers. Okay, so that is the theoretical or mathematical probability of that event happening. 1/3, 0.33, or 33%. All right? Okay. Let's take a look here. This is similar to example 6 from page 464, and it says a gerbil is randomly selected from a gerbil-friendly habitat that contains 3 green, 4 yellow, and 5 blue gerbils. Determine the probability of getting a green gerbil, green or yellow gerbil, orange gerbil, or a green, yellow, or blue gerbil. Okay, so let's see, green gerbil. So we, again, if you're going to write this, which they didn't necessarily ask you to do, but we'll do probability of green gerbil. Okay, is going to be, and it's the green gerbils, which would be what, 3 green gerbils over the total possible gerbils. So there's 3 plus 4 is 7, plus 5 more is 12. So it's 3 out of 12, which is a fourth, or 25%. Usually people will put it as a fraction, and if you do it as a fraction, it's got to be a reduced fraction or a percent. I guess you really could do or 0.25 as long as you don't write percent after that. All right. B, a green or a yellow marble. So again, there are, marble gerbils. Again, there's 12 gerbils, and then green and yellow, there are 7 out of 12. So you could, again, just leave it as 7 out of 12, or we could take 7 divided by 12, and we get 0.5833. So let's do or 0.583 or 58.3%. Okay, any one of those would work. Probability of an orange gerbil. Well, let's see. Again, there are 12 total gerbils, and there are no orange gerbils. So 0 or 0% chance, or no chance. All right. Green, yellow, or blue gerbil. Guess what? That's all 12 of them. So 12 out of 12 gives us 1 or 100%. That's gonna happen. All right. All right. Let's take a short little video break, shall we? This is a very short one, and I kind of like the game show one, so I'm gonna try this again. See what you think.
Reason you might stay indoors on a beautiful day.
Because it's raining?
Oops.
Something made of wool. Sheep.
Sorry, I probably spent a little bit too much time watching that, but that's okay. Let's see. I think we did that one. Yep. Let's do this one here. Complementary events. Complementary events are a set of events where one of the events must occur. Okay, the sum of complementary events is always 1 or 100%. So, example would be probability of, say, rolling a 4 and the probability of not getting a 4. So the probability of a 4 plus the probability of not getting a 4 is going to equal 1 because they're complementary events. Okay, so it's going to be one or the other. Another way to write that would be the probability of event E and the probability of the prime of event E. Okay, so those are complementary events. Let's just take a look at an example that might help out. Okay, so from a standard deck of 52 cards, determine the following probabilities given that you draw one card from the deck. Okay, so probability of drawing a 4. First off, you have to know how many cards there are. There's 13 of each card in every suit, and there's 4 suits. So there are 4 times 13 for 52 cards total. Okay, so the probability of drawing a 4, again, there's 52 total cards to choose from, and the probability of drawing a 4, there are 1, 2, 3, 4 of those, so 4 out of 52, which is 1 out of 13, or let's see, 1 divided by 13 gives us 0.769, so let's do 7.7%. I keep doing that, or 7.7%. Again, you could do 0.077 also. Okay. Probability of a red 2. So again, there's 2 red 2s out of 52 cards, which is 1 out of 26. And we could figure that out. 1 divided by 26. It's going to be 0.385, we'll call it. Let's see. Why is it not wanting to go away? There we go. So that is 0.385. No, it's not. 0.0385 or 3.85%. Okay. Now, probability of not 8 of hearts. Couple ways you can do this really is you could go through and count all of the cards that are not 8 of hearts. Or really what you're going to do is you're going to figure out, okay, 8 of hearts is 1 of the 52. So we want the complement of that, which would mean the other 51 out of 52 cards. Okay? So that's how we use the complement to figure out some of these probabilities. So let's see, we could figure out the percent on that one. And we get 98.1. Or again, 0.981 would be fine as well. Okay? And then the probability of not a red face card. So these are all the face cards down here because they have faces on them. Not a red face card, so 6 of them are red face cards. So again, we'd find the complement of that, and we do, let's do this. Let's do 52 minus 6 all over 52, right? Because there's 6 of them that are red face cards, so that's going to give us what, 46 out of 52, right? So let's see, 46 divided by 52 gives us 88.5%. Okay, 0.885, or again, you couldn't leave it as 46 over 52 because that is a this is not a reduced fraction. Let's see, or so what you could do also on this to reduce your fraction, you should be able to do math and then change it into a fraction. So math enter, and reduce it down to 23 over 26. Or you could have just divided the top and bottom by 2. Okay. All right, so that's all there is for 14E. If you have any questions, please ask. Thanks.